Ever wondered what object-oriented programming is and why it matters? Well, let's dive into it. Object-oriented programming, often shortened to OOP, is a way of programming that's centered around objects. Now, you might be thinking, what exactly is an object in this context? An object in OOP is an entity that holds data and code. The data is stored in what we call fields, and the code is stored in procedures, sometimes referred to as methods. But why does this matter? Why is OOP important, especially in web and mobile app development? The answer lies in the simplicity and efficiency that OOP brings to the table. It allows programmers to create modular code that's easy to maintain, modify, and debug. It also promotes data abstraction, encapsulation, and inheritance, which we will delve into later. So in essence, object-oriented programming is all about creating objects and using them to make programming tasks easier and more efficient. Now that you have a basic understanding of what object-oriented programming is, let's delve into its key concepts. First up is encapsulation. Picture a capsule, if you will. It's a neat little package, isn't it? This is exactly what encapsulation does in programming. It wraps up the data and the methods that manipulate the data into a single unit. This prevents the data from being accessed directly. Instead, the data can only be accessed through the methods present within the unit. This concept helps in maintaining the integrity of the data. Next, we have inheritance. The term is quite self-explanatory. It's a mechanism that allows one class to inherit all the properties and behaviors of another class. Think of it like a family tree. A child inherits traits from their parents, right? Similarly, in programming, a child class inherits properties and methods from a parent class. This concept promotes code reusability. Now, let's talk about polymorphism. A bit of a tongue twister, isn't it? But don't worry, the concept is pretty straightforward. Polymorphism allows one interface to be used for a general class of actions. It's like having a single interface with multiple functionalities. To put it simply, the same method or function can perform different tasks based on the context. Finally, we have abstraction. This concept is all about hiding the complexity and only showing the essential features of the object. It's like using a car. You don't need to know how the engine works to drive the car, do you? Similarly, in programming, abstraction allows you to hide the complex details and show only what's necessary. So, these are the 4 pillars of object-oriented programming: encapsulation, inheritance, polymorphism, and abstraction. They form the foundation of any OOP-based application. You might be wondering, why should I care about object-oriented programming? Well, let's delve into that. Imagine constructing a building. Without a solid foundation and a well-thought-out plan, the process becomes chaotic, time-consuming, and prone to errors. That's what software development is like without object-oriented programming, or OOP for short. OOP provides a clear structure for your programs, making development and maintenance more straightforward. It's like having a blueprint for your building, guiding every step of the construction process. But the benefits don't stop there. OOP also provides an excellent framework for code libraries. What does this mean? Well, it means software objects can be easily manipulated, modified, and debugged. It's like having a set of building blocks that you can rearrange and tweak until you get the perfect structure. In conclusion, object-oriented programming is a powerful tool that can help you create robust, flexible, and easy-to-maintain software. So, we've learned a lot about object-oriented programming today, haven't we? We started from understanding what it is, a programming paradigm that uses objects and their interactions to design applications and software. It's all about creating objects, manipulating them, and making them work together. We then delved into the key concepts of object-oriented programming, which include encapsulation, inheritance, polymorphism, and abstraction. Each of these concepts plays a vital role in the development process, providing structure and clarity to your code. We also emphasize the importance of object-oriented programming in software development. It's not just a fancy technique. It's a practical approach that allows for code reusability, scalability, and efficiency. But don't let this be the end of your journey. There's so much more to learn and explore in the world of object-oriented programming. Remember, understanding object-oriented programming is key to becoming a successful web or mobile app developer. Keep exploring and happy coding.